won't start.
Oh, that
Insane.
sucks.
Mine struggled.
I think I'll have a new car for school today, actually.
I was like,
Mine struggled pretty bad.
You know, like,
Like it turned on, it turned on, and turned off. I was like, what?
So my car won't even turn on.
I'm so happy I didn't have to scrape my car this morning.
I think the cool that leaked out after a whole day.
Are we dialing, guys?
To relock it.
I've never been
It's so warm and dry. I just want to take a nap.
I had too much coffee today. And I hadn't been using most of it, so I'm like ready to go 1,000 miles an hour. Slow down. Okay, all right, first derivative test. What did that show us?
It showed. I actually
First derivative test showed us.
You know what I'm saying.
Just dig out
the
some
average, the slope, increasing,
Concavity.
positive or negative.
Now this one's concavity.
This
Maximum,
one.
minimum.
Maximum, there we go. All right, we finally got those words in there.
Just kidding.
All right, first derivative test shows you maximum minimums. Those are called what?
Extremists.
No.
They are extremists, but I'm looking for a different word.
Letters.
I'm looking for a C word.
Oh!
Maximum mins are also called
Hang on.
Consider the numbers.
Concrete.
the numbers.
Wait.
Concrete.
This is critical that you know.
Critical.
Critical numbers.
Okay. So first derivative test shows your critical numbers as max or mins. The second derivative test shows your critical numbers as concavity. So it's going up or going down. Okay. Now instead of calling them max or mins, we call them points of inflection. Or I'm just going to use POI. POI, which stands for points of inflection. That tells you when you're going from concave up, concave down. We know a little bit about concavity already, but let's unpack just a tad bit more, because now we know a little bit about this. This graph on the left. Is that concave up, concave down? Concave up. Any tangent line you draw on a concave up graph will always be under the line. So we see that? With this tangent point right here. The tangent line is always beneath it. What about concave down? Tangent line is always above it. I don't care where you draw your tangent line at, it'll always be above it. So concave up means f prime of x is increasing. What's concave down then? Decreasing. Means f prime of x is decreasing. Cool. All we're doing is taking our first derivative test and building on it for a little bit. There are third, fourth, and fifth derivative tests, but we just don't talk about those because they're really not useful in the real world. When I say real world, I mean the actual physical space we exist in. It's not like somebody's going to go ask you about concavity when you're doing your taxes, right? However, there is a use for it, just not in the physical world. Cool. We good here? Let's go to the page. Determine the intervals on which the graph is concave upward or downward. State the point of inflection and explain how you know. So surprise, surprise, what are we going to have to do with this function? Take the second derivative of it. So let's do the first derivative. So f prime would be what? X squared minus 1. Cool. But we're not asking about maxes or mins. We're asking about concavity. So we're going to do the second derivative. So what's f double prime going to be? Sweet. Now taking a step back to first derivative test. we set this equal to 0 to find max or min, right? So we think we're going to do this to find point of inflection. Set equals 0. 0 equals 2x. So our point of inflection is at x equals 0. That's where the graph is going to go from concave up to concave down, or concave down to concave up. We don't know. So how do we find out maxes and mins? We did a little test, right? So instead of saying f prime, we're going to say f double prime. What's my critical number? 0. So I got to pick a number to the left of 0 to plug in for f double prime. -1, -2, doesn't matter. What does it give me though? A negative number. Really? I'm gonna slow down just a second. I feel like I was speeding up just a tad bit too fast.
That's plugging it into the second.
Yeah, if I plug in -1 into here, what's -1 times 2? -2, so it gives me a negative number. Let's do a number to the right of 0. 1. What's 1 times 2? 2, so it's a positive number. What is it going to do if concavity is negative? It's going to be downwards, right? And if it's positive, concavity is going to be
Smiley face.
upwards, right? Smiley face.
So it would look like.
It would probably look something like where that is 0. We are going to do some graphing ones with our graphic calculator. I don't know if we'll get to it today. I doubt we will. But. Okay, let's do the interval where it's explain the intervals where it's concave upward, concave downward. So what interval is it concave upward? 0 to negative. 0 to what? Infinity. 0 into infinity. Our interval is concave up. And why do we know this? Because what is positive?
Double.
F double prime is greater than 0. We can't just state it's concave up. We have to explain how we know. And we know because double prime is greater than 0. So then the contrapositive to that would be what? Negative infinity to 0 is concave down because f double prime of x is less than 0. Did I fully answer the question? We need the point of inflection. Where is the point of inflection? At 0. So the point of inflection, POI, is at x equals 0. Explain how we know. How do we know the point of inflection is at x equals 0? F prime to 0?
Oh, because they changed.
Because what changes?
Inflection.
Because concavity changes.
Everything that goes from
Changes from down to up.
You said negative.
Yeah, I think it would work. From down to I you erase? The only thing, Jen, I would make sure we explicitly say, we would say F double prime changes from negative to positive. If you just say negative to positive, well, that means this goes from negative to positive, or this goes negative, or that goes negative to positive.
Could you say the concavity?
They can assume a wrong answer.
Could they say the concavity goes from negative 0 to negative positive?
Yeah, that'd be okay. You explicitly want to connect this point of inflection to concavity change. Cool, not too bad, right? I'm just going to scooch down here. This picture, or these two graphs, correlate to the question above it. Okay, so now we're just going to draw those graphs. Before I can do that, though, I have to find max and mins. At least that's the way I did this problem. How would I find my max and mins with what I have? Set the first derivative equal to? 0. So f prime of x squared minus 1. Go ahead and set that equal to 0. So x equals positive negative 1. What are these called again?
Extremists.
Critical numbers. They're extremists. Max or mins. I don't know which one's which yet, so I have to test it. So let's test it. We got negative 1, 1. I didn't really choose a good color here. Sorry if it's abrasive to your eyes.
You're just reviewing.
We need our max and minimum to draw a graph here.
Plus.
So let's pick a number between less than negative 1.
2.
Negative 2. Negative 2 squared is 4. 4 minus 1 is 3. So that is positive. Means the function is increasing. The slope is positive. Choose numbers between 0 and negative 1. Or sorry, 1 and negative 1. 0. 0 squared is 0. Minus 1 is negative 1, so that's negative. What do I got to the right? Right of 1. Pick a number. 2. 2 squared is 4. Minus 1 is. This went from. So what do I have at negative 1? We have a max, right? We got a max at negative 1. And what do we got at 1? We got a min. Here's what I want you to do now. We have all of this information to graph this. We only have 3 points, 3 critical numbers. We got 0, positive 1, and negative 1. With what we know, we should be able to graph this relatively to scale. Try it out for me. Piecing all the information we got. And I'll fix attendance. Okay, now here's how I piece it together. just give you one hint. I know I've got a maximum and a negative one. I got a minimum of a 1. At 0, we know it's a point of inflection. It goes from concave down to concave up. So watch this. Concave down, concave up. Right? What's it going to do after 1, though? It's going to keep going up? Brady? I agree with you, man.
How do you know it goes below that axis? Like
Below the x-axis. Well, because
Wait.
this,
Like how do you know that it goes to the
because we have a point of inflection
at 0?
at 0.
And how did we figure that out?
That was our second derivative. That was right here.
Oh, this. Oh, because it's the same function. Okay,
Yeah, it's the same function as above. What are we graphing for the one on the right? Prime, right? We're graphing the prime graph. Well, before I do that, let's even talk about this. Does our information match up with what we have so far? Is the slope there 0? Checks out. So f prime at 1 equals 0. What about here? F prime at negative 1 equals 0. F double prime at 0 equals what? Because it goes from concave up, down to concave up. What are my critical numbers again? All 3 of them? Negative 1, 0, and 1. So we got negative 1. Let's do her color. Negative 1, 1, 0. Put that. Positive 1.
Oh, so the point of inflection is a critical number.
Yes. It is also a critical number because it tells you some sort of information. I'm going to use my information from right here to help me graph this right here. This is the slope, right? What is my slope doing outside of 1? So I start here at 1. What's my slope? Cool. What are my slope values outside of negative 1? Positive. What are my values from negative 1 to 1? They're negative. Let's go with something like because we know in order for it to go through the zero, one of two things would have to be true. Our function would have to do this, or my function would have to do this. Follow me there? This one has how many critical numbers? This one has how many? 1, 2, 3, 4, 5. Follow me there? Now back to something we did a long time ago. Oh no, oh no. Remember, what was that little easy way to count the powers for your graph? And how many turns it should make?
Oh yeah, how many things?
This is a cube term, right? We got 1, 2, 3.
How many times it changes direction?
How many times it changes direction? 1, 2. All right. So that always works. Always. The one where it does tend to get you though is if the function does something like this, because it's easy to miscount it. What if my function did?
That's 3.
3. Because it's 1, 2, 3. So that's still a cubic function. It goes perfectly flat. Okay. Time to get out of here. Time to get out of here.
I'm gonna say
12
12.
o'clock?
Yeah, 12.
How about we do up to example 4 and call it done?
Do you answer these ones above?
Yes, we did that already, but I did not put them in the spot. So f prime of x
I thought I was asking what it was.
no, we already did
So
it.
we were like wanting
Negative, positive. So we already did it. Positive, negative, positive, up, down.
I thought they would like well like they.
Looking at this first one right here, I'm going to draw a point here. We'll call that point P. What can I say about the slope at point P? Positive, this is great, 0, absolutely. And what can I say about the double prime at P? We go from concave up to concave down, right? So it's 0. So let's add a couple things on there.
PY.
It goes from concave up, concave down. Happy face to a frowny face, which means double prime is 0. POI. The point of inflection would be at P. Point P. We don't know the Y value for it, so I can't write the coordinate point. What's weird about this one? It's got a little flatty part. We're gonna say about that little flatty part. Do we still have the concave down? Concave up? So what can I say is right here? Your point inflection. say at point P. So I can make the same statements I made here for here. But what is my slope though at P? That's 0. Because it makes a flat line.
So F prime is.
So F prime at P would equal 0, and F double prime equals. But Mr. Wiggs, how in the world would you make that happen? Usually this happens for trig functions.
Ugh.
These are usually polynomials. These are the trig functions. What's the problem here though?
Oh wait.
If I draw my tangent line, let's draw my tangent line in here.
That doesn't exist. Because it's up down. The up down.
Absolutely.
What's that one thing called? The up down check.
Vertical line test?
Yeah.
That's a test of a function is a function of a function. So F double prime at P does not exist.
Can you explain that again? Why is it not?
F prime of P creates a vertical line. What's the slope of a vertical line?
Oh.
Does not exist. If the function does not exist for the first derivative, it definitely doesn't exist for the second.
Yeah. 11.
And lunch is at 12. So the bell ring for you guys at 12. 'Cause right now it's B lunch. They get 11:30 to 12. What are the 3 instances where functions are not continuous?
Cusp.
Unbounded behavior.
Unbounded.
When are functions not differentiable?
Split.
Cusp.
Jump.
There's jump, right? I guess when functions are continuous but not differentiable, there's a cusp. Right? So looking at these. How can I say we have an inflection at point P for this first one? Well, it's continuous, right? And differentiable. Doesn't break any of the rules. And it's concave down to concave up. That tells me we can say F double prime at P equals 0. What problem am I going to run into down here? We got a cusp, right? So it is continuous, right? Is the function continuous? Absolutely. There's a value for every single x. However, it is what? Not differentiable. Since you can't take the derivative of it, that means F double prime is what?
Does not exist.
You guys, rock stars. What would I say for this right here? It's a cusp, so it's continuous, but not differentiable. So F double prime of x does not exist. Hot dog.
This is not
And not differentiable, right? We good here? Just like mostly some vocab. Basically bring up old stuff. Like to dig up old news, just can't ever get rid of it.
Fake news. Do you see Vivek Ramaswamy dropped out of the race?
No.
What did you say?
Vivek dropped out of the race. Vivek Ramaswamy. He dropped out
Oh
of the
no!
race.
He was fun.
Suspended his campaign.
Like this morning.
Alright, here's what you try for me. Try number 3. Very similar to what we did earlier. Get as far as you possibly can get. They give you some things to work with already. Determine any points of inflection and discuss concavity. So do I really need to find that prime and do something? You could, but I just wasted your time. See if you can get the critical numbers for concavity. Tell me where those point of inflections are at. And then tell me when the graph is concave up or concave down. Psych.
Oh, that's what that was for. That's why I got it.
Everybody get the critical numbers of 0 and 2? Why did I need to find my y? Ask you, give me the point of inflection.
Does that tell us where you change
Yes, but if I ask you specifically, state the point of inflection, you need the x and the y coordinate, right? So point of inflection number 1 is at 0, 0. Point of inflection number 2 is where? 216.
Can you plug it into the secondary key?
Just the original. So just the original function. Plugging in 0 to the original function will get you 0. Plugging in 2 to the original function will get you 16.
Wait. How do you know which one to plug it into? Because in the one. But when was it? In the first example, we plugged it into the second.
That was to test it. I haven't done any of the tests yet. Haven't done any of the tests yet. Is everybody good up to here? Now we got to test some numbers. We're going to test f double prime. So what's the number left of 0? -1. So let's try -1 out. So that's going to be 12 -1 squared minus 24 times -1. So it's going to be 12 plus 24. Right? Is that a positive or negative number? Positive. Which means it's going to be concave up. What's the number between 0 and 2?
1.
1. So at 12, 1 squared, 24, 1. So that's 12 minus 24. That's going to be negative. Let me put a line here. Negative. Cool. Number bigger than 2? 3. I'll just go ahead and tell you that one's going to be positive. We're at concave up, concave down, concave up again. So last piece is discuss concavity. Give me the intervals in which you're concave up, concave down. Let's do this in an abrasive color. We are concave up in what interval? -infinity to 0. And 2. Sweet. Are 0 and 2 included? Concave down would then be where? 0 to 2. I'm going to say what I said earlier, and this is absolutely just building upon for units 1 and 2, right? Taking derivatives and then just doing stuff with them. So I don't think the rest of the year is going to get tougher. I just think it's just going to be doing more stuff with it. Can we see, though, how it's like super important to like get units 1 and 2 down? Imagine if we had a big class and somebody still didn't know how to take a derivative at this point. Love small classes.
So how do we know at 0 and 2 that it's 0?
The excuse me, the f double prime is 0 because we set the equal to 0 here, and that's how we found our x. We went ahead and set the 0 here and told our x is 1. We found 0 at the. Cool. Great question.
So if I plugged in like 2 that information, would I get something?
You should. So what's that? Let's do 2 squared is 4. 4 times 12 is 48. Minus, what's 2 times 4? 24. 40 times 4. Okay. Last problem will be done for today. We're gonna take one more step. Second derivative test, but we're gonna include what now? Trig. Why do we need to pay attention to our integral though when it talks about trig? 0 to 2 pi. What if my interval was infinity? Right. You just keep going. So we're looking for one full rotation. Let's try this out. Okay. G prime of x is going to be what? 1/2. That's the easy part. Derivative of sine is cosine x. Cool. Double prime. Derivative of cosine is negative sine. Man, aren't we so thankful we remember those derivatives? To find point of inflections, what am I set my double prime equal to? So 0 equals negative sine. So when does sine, I gotta hold it real quick. When does sine x equal 0? 0 and pi and 2 pi.
Yes.
So 0 and 2 pi are like the same point.
One's got a full rotation on it. Now, let's put our big brain on real quick. Am I testing anything outside of or anything less than 0? So can I definitively say anything about what the graph is doing less than 0? So we're not going to test 0. Because we're not doing anything less than 0. Same thing for 2 pi. Am I looking for anything past 2 pi? No, so we actually don't test 2 pi either as well. So what's our only critical point that is included on the graph for the entire function? That's pi. So our only critical number we care about is pi. We go from 0 to 2 pi though. So when we choose a number, we do have to be a little bit more careful. We can't choose infinity. We can't choose negative infinity. We're only looking at 0 to 2 pi. But the only thing we're actually testing is pi. What's the difference between 0 and pi? Pi over 2. 1 is that, but we can't really test 1 on a unit circle. Okay? At pi over 2. This is G double prime. Pi over 2. Everybody agree pi over 2 is you? What's sine of pi over 2? 1. What's negative sine of 2? So this could be a negative value. Who's there?
This one, the one that's calculated is 3 pi. I don't remember.
Everybody.
Pi.
It's not spelled like three, like three.
No,
Spelled differently.
it's spelled different.
Great. Help her out. Never mind. Okay. I need it back though by the end of the day, okay?
Alright, thank you.
Absolutely. Well, you found this to be negative, right?
Yeah.
So let's pick a number between pi and 2 pi. So we got pi. 3 pi over 2. So what is that going to be? Sine of 3 pi over 2 is negative 1. So it's going to make it positive. Cool. point of inflection. Point of inflection. We don't know the y value yet. We do know about concavity though. Concave down, concave up. So where am I gonna plug this pi into right here to find out that y value?
The original function.
The original function. Original function. Because we want to find this. So for my original function, we're going to plug in pi. So that's 1/2 pi plus sine pi. So g pi. Well, that's just pi over 2. Sine of pi, 0. So this just turns into pi over 2. Now I've got my point of inflection. Now we talked about earlier, why is 0 not a point of inflection? We didn't test for anything left of 0. Same thing, 2 pi isn't a point of inflection because we don't anything to the right of 0.
And is that because it's in brackets?
It's just the interval we're looking at. It doesn't have to be in brackets. It could be parentheses as well. Okay, now I know my point of inflection is there. What am I concave down? 0 pi, not included. What am I concave up?